Hello, hello. I'm so happy to have Tom Szaky, the CEO of TerraCycle, who's a very, very busy man. It's been tough to get you, Tom, and I'm so excited about this interview because we come at the same challenge from a very different perspective. Of course, most of our work is around compostability, and you're doing such amazing work in the recycling industry, and you've been at it for such a long time. So I'm actually really looking forward to learning from you. So thank you, Tom, for joining in and making time for us.
Thanks for having me.
Great. Tom, I'm going to start early on because you've had a very interesting childhood. And I saw you are a son of two Hungarian doctors and you shifted early on to Canada. But what I want to know is that, were there early influences in your life that led you to this whole passion that you're being driven by?
Yeah, absolutely. I think there's probably two big ones for me. I think one is, when I was born in Budapest in '82, it was still under the Iron Curtain, which only went down in '89. And so, of course, it was, growing up as a young kid in still a communist country. And in '86, Chernobyl happened in the Ukraine, and that destabilized the border. So my parents effectively fled as political refugees with me in tow. And we spent 3 years, trying to seek asylum somewhere. And Canada is what let us in at the very end. So I got there at the age of 7. And that is, for me, one influence, not as much the escaping, but going from communism to capitalism and falling in love with entrepreneurship and this idea that you can, through, and really North America is very much a meritocracy in most senses, more than other regions of the world. And so that was a major influence to wanting to be an entrepreneur. I also think in growing up in a country that was very poor relative to North America, the idea of throwing things away had a very different context. So in Hungary, if you wanted to get a television, you had to apply to the government, and maybe you would get one, and we didn't have that privilege. When I landed in Canada, the first TV I ever got was one I found in a dumpster in an apartment building, and it was in color. And it was like you get them all the time. And so it was so interesting to see the shock of waste. But I think both of these are about being on the other side of the fence and then realizing it when you're there. It's maybe a little bit harder to have these realizations if you grow up in them.
Yeah, and I grew up in India and I remember those times as well. It was a socialist economy, and I remember people would book a telephone and it would take 2 years to get a telephone, or a scooter and it would take again, or you went to the black market and got, paid double the amount or something. So that's really interesting. I definitely want to learn more about the entrepreneur bug, but what I want to dive into first is what influenced you to think about waste, and what made you think that, okay, you want to do something about it? How early was that, those influences?
For me, the entrepreneurship bug at the very beginning, in my early ages, like 11, 12 years old, was really to fulfill, I think, very selfish goals of I figured it was my fastest path to fame and fortune, both very egocentric goals, for a little kid. And I started my first company when I was 14, then did some other ones, but none of them had purpose as a center. And I had this huge turning point, first to purpose, then to waste, where I remember this, and one of the first classes at Princeton was Economics 101, Intro to Economics, and the professor gets up on stage and asks, I think, a very reasonable opening question, which is, class, what's the purpose of business? And the answer she was looking for was maximize profit for shareholders. And I was like, okay. It just was unsettled. It wasn't like an inspiring answer, even though it's maybe technically the correct answer. And so I meditated on this a lot, and where I landed was, I think profit, being critically important, mind you, is not the purpose, but an indicator of health, right? Critical, because if you're unhealthy, you will not survive as a company, and you will definitely not thrive. And if you are healthy, the opposite will occur, but it's more like an indicator of health than it is the sole reason of being. And so then I said, well, if I can move it as an indicator of health, and keep it very important, of course, then it leaves room for something else to be the purpose. And so that created this search for purposeful for-profit business models. And I sort of ran into the topic of waste, and it's become a lifelong fascination. And the reason waste is so eternally fascinating to me is, one, it is a very big problem to solve, right? So it has the purpose to it, which is wonderful. Not all business things have purpose, right? But waste really does if you solve it. But then, much cooler than that even, is it's filled with really phenomenal anomalies. So I'll give you a couple of them. In economics, we were studying at nauseum supply-demand curves, right? And you think about what happens when there's more supply, less demand, what happens to the price, and where do those two things intersect? And I was thinking, like, where do you draw the supply and demand of garbage? And in fact, you can't draw it in any textbook because all the supply and demand curves intersect in the positive quadrant. They have a positive price. And garbage has huge supply, no lack of supply, but it has negative demand. And that idea of drawing an intersect in the negative quadrant is not talked about in a single economics textbook. That is interesting. Or, isn't it interesting that the garbage industry will legally own everything we possess, capital E everything, right, one day? In fact, 99% of what we buy within the year of purchase. And for how big of a statement that is, and I mean everything, even the walls behind us, like everything, isn't it interesting that it's also the least innovative industry per dollar of revenue it enjoys? And I believe it is, because look at, for example, where you're from, and if you think about where it stacks in the hierarchy societally, it's probably the very lowest. It is literally smelly, nasty, gross, not metaphorically, and so no one's attracted to it. And these are just two anomalies. And it's filled with these, which makes it a really also academically interesting place to build business models.
I have definitely never looked at it like that. So thank you for that. And the idea that everything will become garbage is definitely a super interesting one, which we don't think about enough, I guess. I want to pivot.
And way sooner, the key here is like way sooner than we think. That's the insane part, right?
Yeah, absolutely.
The average textile someone buys today, they only wear 3 to 5 times before disposal.
Yeah.
Most goods don't, last more than a year. And even the things we view as durable may only last, like look at the computers we're on, probably will only be, good to us for another 2 years.
Yeah, which is also very interesting. If you think about us growing up and, the refrigerators would easily last 20 years. I remember being in a house where a refrigerator was 20 years old. It was working totally fine. And the same was with other things. But I think you're right. People are not even, as organizations, we are not even creating things to last and to be that durable. And you talked about clothing. It's designed to not last long.
100 years ago, an average garment would last 20 years. People would mend it, fix it, so on and so forth. Today, it's 3 to 5 uses. I was shopping for an oven recently for just a cooking range, for our home. And I couldn't believe this. The salesman comes up and he says, you should really buy insurance on that because they're just not made with the quality they used to be made with. This is the guy selling me the oven.
Yeah. And I see that. Yeah. Absolutely. Yeah. Like anything you buy today is definitely not the same as it was. I want to actually pivot. You are a son of 2 Hungarian doctors and you decide to drop out of Princeton in a year. How was that for the family? And, I was intrigued by that, I know I have Hungarian friends. I know how important it is to be a doctor, an engineer, and a lawyer, or one of those. And then there you have this son who's in Princeton, which is a great thing. But then he decides to drop out. So what was it like for the family? And then of course, what made you do that?
Look, my parents have always believed in education in that very sort of old country way, and I believe in it too. I love education. I still have the privilege of lecturing at these universities quite a bit and contributing, but so they instilled that in me in a positive way. I was never anti-school. The problem that occurred for me is I knew I wanted to be an entrepreneur from a very young age, and then I started, working on TerraCycle in my freshman year. And by the middle of my sophomore year, I had to choose either excelling at school or excelling at the business. I knew I couldn't do both simultaneously. I had to, and at a school like that, you have to throw yourself into the classwork, or it's not gonna, it's not gonna succeed. And I have to tell you, it wasn't, a big dramatic moment because I was able to ease into it. So a couple of things that made it easy for me was one. Princeton gives you an extra 4 credits equal to a semester if you speak a foreign language. So I had that, through speaking Hungarian. But then also, they don't let you drop out. And what I mean by that is you just go on indefinite leave. And so I took a semester off. And I guess technically, still 20 years later, you can call me on leave, though I would never at this point return. So it was a bit of a softer piece. But then again, too, it was that moment where every child breaks from their parents one day, and that was my sort of moment, too, to be like, no, I am now going out on my own path, and so be it. And it was, one of those moments. They would have loved, I think, for me to finish school and get the diploma and all these things, but it wasn't for me at the time.
Maybe Princeton will call you back at some point and give you an honorary doctorate of some kind.
So, you never know. It's possible. It's possible. I would consider it. But I mean, look, I get a chance to go back, and I lecture there almost every year. So we have a wonderful relationship with the university. I just took a different path, and again, it was, it worked out like this in the end. Like, I stayed friends with all my friends. I just went to work and they went to class, and then we still partied together in the evenings and all this.
Oh wow. Okay, so you were still based in the area when you started your business.
Yeah, my office was literally across the street. We took a basement office. I ended up moving into the office, living in the photocopy room, and now we're in Trenton, which is just 15 minutes south of Princeton. So that's how I ended up in New Jersey, totally unconscious.
Amazing. So I want to actually learn about how TerraCycle started, because I read somewhere it was an idea of something like using worm poop. And then,
yes.
So that idea, and then how does it transform or transgress into this whole huge idea of recycling? And it'll be lovely to hear that story.
Absolutely. So you're absolutely right. TerraCycle started as a worm poop business. In fact, the logo I drew it as a worm eating itself. That's the original concept of our logo, and Terra is earth, cycle. So you can see how that can come together with this idea of worm poop. So our goal, the reason I always jumped into it, was the idea of solving for waste, right? Our tagline is eliminate the idea of waste. And I started the output by saying, let me make products from waste and be a product company. And the first product was feeding organic waste to worms, taking the worm poop and liquefying it, and then from there, packaging it in used soda bottles. And this actually, what I'm holding up, became the first product. You can see it's a used bottle, liquid worm poop on the inside. This is the worm right there, and so on. And where I'm sitting here was a production factory in Trenton of worm poop in a soda bottle. And we grew, year one was like 70,000 in sales, then $500,000, then 1.5, then 3, then 6. And that really is what TerraCycle was for its first 4 or 5 years. What became our transformation, and we've had this many times in our history, where we take a step back and really think through, are we addressing waste at the root cause? Are we, are we fulfilling our mission to eliminate the idea of waste? And what we realize is, by making a product out of waste, the product is the business hero. Now, if the product is your business hero, as it should be for any consumer good company, then you're going to want to pick the very best inputs. And even if we have a rule that the input must be garbage, we're going to pick the very best garbage. So in organic waste, we were picking certain inputs, like coffee grounds from over here, banana peels from there, some yard waste from here, but not all organic waste, because depending on what we fed the worms would affect their output. We were taking uncrushed soda bottles versus dented or crushed soda bottles, because that would, even if we packaged in used soda bottles, the package had to look generally pretty good. And we realized that by making this the approach, we're only ever going to take the very best of the waste. And we're not going to address all of it. And so painfully, it was a very painful pivot. 5 years in, doing $6 million in revenue, we said, let's stop the worm poop thing and imagine ourselves as putting the hero as the garbage. And that was this huge pivot. Now from there, we've been doing less pivoting and more incrementally adding ideas. So, we've developed a recycling business unit that's gotten pretty big now, recycled content, reuse, even discovery. And now it's about a $100 million revenue enterprise. But that pivot was so important to make garbage the center point, not the output the center point.
That's so interesting, and I want to learn a little more about the worm poop, because I'm still intrigued about. Because I thought, in my reading, it's just the initial idea, and you never really built a business from it. But you clearly did.
It got big.
And then the 5-6 million in revenue is decent size. So how did you? So what actually transpired? And you said you took a special, certain kind of garbage, fed them to the worms. What was the output, and how was it used? Tell me a little more about it.
Yeah, absolutely. So the input is organic waste, but again, really picking the things the worms like the most and created the best outputs, right? Coffee grounds is a good example, newspaper, things like that, of that nature. That would come in as raw organic waste. If it needed to be size reduced, we may run it through a shredder if need be, because the worms, really want small particle sizes. Then from there, we would put it into a rotary composter, an aerobic rotary composter, just to get it sort of cooked, if you will, for the worms. That would get up to a high temperature through an aerobic process, and then within a day or two, that material could be put into a machine that we created called a worm gin, where basically the worms would be on a conveyor belt moving towards the input food, and their castings or worm poop moving in the outward direction, like a eating, pooping conveyor belt thing. Then the worm castings, which is the proper term, or we would fondly call it worm poop, that we would then take and make a tea out of, like an emulsion, and so that it could become a liquid fertilizer. And then the what we call post brew, the leftover like tea bags, if you will, from making the tea, could still be used for seed starters or soil amendment or something. It was still used, but then the main product became a liquid fertilizer, and that was then packaged in used 20-ounce and 1 liter and 2 liter soda bottles, so that it could be then sprayed onto plants and used as a fertilizer. And the really interesting sort of thing about that as a product, as a fertilizer product, is most fertilizers focused on petrochemicals, and it's just about what you would call the nitrogen, potassium, and phosphorus, the NPK. That's really what it's trading on. Worm poop and most organic, truly organic fertilizing products don't have high NPK, because that's artificial. But what they do have is an incredible biome of microorganisms that fight disease, help encourage acquisition of nutrients. I mean, it is absolutely phenomenal and interesting what it has, and that allowed really good performance to occur against the very high NPK or high nutrient content fertilizers.
Tom, that's absolutely ingenious. And the great thing about that is not only did you take this crazy idea, but you actually made it happen, which is truly fascinating and also impressive that it could actually be converted, because I definitely try and compost as much as I can. At one point we were using these bokashi systems, and one of the things that came out of it was this tea, the compost tea, you called it. And then yes, you're right, it was so beneficial for the soil, and I'm so intrigued that you actually managed to convert it to a business and sell and get revenue. But of course, we are here to talk more about TerraCycle and what it does now. So tell us more about the business model, how it works, and then of course we'll delve deeper into certain aspects of it.
Absolutely. TerraCycle today has 4 major divisions, and we fondly call each of these a tree in our forest. And so the first one is our biggest, which is focused on the value proposition of recycling. And what we do there is we set up scaled solutions to be able to collect and recycle anything that someone is willing to fund. And this is an important subtext, that what makes an aluminum can highly recyclable in most countries around the world, and what makes a toothbrush not recycled in any country in the world, is not that one can be and one can't be. It's that on the aluminum can it's easy to make money, while recycling a toothbrush you'd spend more money to collect it and process it than the results are worth. And so TerraCycle focuses on more like the toothbrushes, and we do that by constructing business models where we can get funding that offset the cost so that we can go out and collect and recycle these things. Our second division focuses not as much on collection and recycling, but helping companies make their products using recycled content. So it's more of a content supply division. Our third division, under the brand Loop, focuses on how do we shift from disposable consumption, where the best thing to do is recycle and make from recycled content, to reusables. And then finally, our Discovery division has less to do with circular economy and much more about elevating waste. Discovery has the thesis that certain waste streams are great carriers of diagnosable samples. So your air condition filter is a great carrier of the mold and mildew in your air, just like your child's diaper is it's a medical grade carrier of a fecal sample. And so there, for example, we have a platform that just launched with a big diaper brand where you can buy a kit through tinyestbiome.com, I think, and send it in, and it goes to a laboratory that analyzes the microbiome in the fecal matter and predicts childhood allergies, brain development, immune system efficiency, all sorts of different interesting things. And so that's today what makes up our organization.
That's again so interesting, and it's fascinating to see how you're coming at it from different angles as well. You're not leaving one thing to chance. And of course, I again read somewhere where you were handling really difficult stuff, like you mentioned diapers and cigarette butts. How does that work? And are you talking about poopy diapers? And then how do you actually, what do you do with it? And how does that work in the system?
Certainly. Well, you mentioned cigarette butts. If you, they are the number one most littered waste stream in the world. And we're actually very proud that soon, in the coming months, we will be celebrating our 1 billionth cigarette butt collected and recycled. So each waste stream is a different animal. How you treat a dirty diaper is different than how you treat a cigarette butt, which is different than how you treat a razor blade. All three of those, mind you, we work on, and hundreds of others. So each waste stream has three things that have to occur. You have to collect it, which is not just physically transporting. It's what collection bin is it in? What is the incentive? How do you get people to do it, access it? All the stuff that gets it from your hands to mine. Then you have to process it. And then you have to build a business model to make someone fund it, right? Because again, what makes a cigarette butt or a razor blade or a dirty diaper not municipally recyclable is that it costs more to collect and process than the results are worth. So let's break these apart and just compare them. I'll compare a razor blade to a cigarette butt, just to give you two ends of the spectrum. Cigarette butts, if you look at collection, they tend to be collected either in city environments, like cigarette collection bins on the street, because people are smoking outside. So instead of throwing them on the street, they throw them into one of our cigarette recycling units, or in high frequency smoking destinations. Believe it or not, cruise ships and casinos take the cake for where people smoke the most within controlled environments. So there we develop the right bins, the incentives and so on, and get those collections to occur. Inversely, a razor blade, you're going to see that collected and recycled at places where people change a lot. Like think sporting event venues. For like where you and I would do sports, not go to watch sports, but when there's big changing rooms. So if I go, like that's a very intuitive place where people may shave, or colleges, universities, because there everyone's living together, right? And then at home, of course, is another environment. So we set up the right, and there you have to worry about health and safety so that you have the special devices that when you put in a razor blade, you don't have the risk of being able to touch other dirty razor blades that may be in there. So it's slightly different. Then when it comes in for processing, cigarette butts, we shred them. We separate the ash, tobacco, paper, and compost it. We take the filter, which is made from cellulose acetate, and then recycle that into everything from railroad ties all the way into ashtrays, right? That's where that material can go. It's a plastic, actually. Many times people think it's more like a cotton, but it's just a foamed plastic. Then on the razor blade, that's made from some rubbers, some metals, and plastics. We shred them, and we effectively separate the ferrous and non-ferrous metals, as well as the floating and sinking forms of plastic, and then those all go into downstream applications. In fact, we are trying to work with an organization now who makes razor blades to make the world's first handle from handles. It's not yet out, but it is in an R&D process, so that may come. And then in each case, the funding source, that's the third part, is the business model. In cigarette butts, it could be cities funding it. It could be the tobacco companies funding it. It could be the cruise ships and the casinos. While in razor blades, the razor blade brands like Gillette and Bic fund our programs. It could also be retailers. You can go to a Monoprix in France and drop off your razor blades in their TerraCycle recycling kiosk in their stores in France, all the way to barbershops and other places, right? So it's also figuring out what is the right funding channel to get all this paid for.
And it's again so cool that you're actually tracking the number of cigarette butts. I was amazed that we're soon going to do our billionth, cigarette butts. That's right. That's amazing. So staying with the idea of input, the way I've seen recycling work effectively is better segregation at source, and rather than segregating later. Are there things that you're doing through different programs to enable that? Because when I see US, there's not that much segregation at source. Somebody takes it and somebody then has a segregation site, which the complexity is already been created. And how do you think about that? How do you think about segregating early on?
It's a very good question. I think segregation has to happen at some point. Before you can't just mix all the garbage together and run it through a process and expect anything other than garbage to come out. So you need to have segregation happen. Now, it's the question is where, and it's really a question of cost versus convenience. One would argue that if you have it done by the consumer into hyper-segregation, that is less convenient for the consumer but lowest cost for everyone else. And if you do like the US does in normal recycling, single-stream recycling, where you don't ask the consumer to separate, then it's easier, more convenient for the consumer, but more expensive down the line to do the separation. So it's a tension of convenience versus cost. Now, so generally speaking, the better we can get, the more we can push it up to the consumer, the better, because it does remove cost. And it turns out consumers are very open to separation, more than one would assume. And the more you ask them to separate, the purity level goes up, right? So if you ask someone to separate into one category, purity may be 60%, 70%. But when you ask someone to separate into 20 categories, it's 99% purity. So there's a nice effect of purity that goes up in that direction. You can also alleviate the perceived inconvenience through incentives. Incentive could be fun. It could be benevolent, like the stuff you collect in this bin will turn into a playground. And it could also be direct monetary, like bottle bills and so on. But in the end, it has to be separated. So now a good example of measuring this tension, we have a division called our Zero Waste Box division, which is basically where you can buy recycling solutions from us, while we have brand and retailer funded ones that are free to the consumer. Now I use the Zero Waste Box division to answer your question because there we offer boxes with hyper segregation at lower prices, and boxes where you don't have to do hyper separation, even what we call an all-in-one box, but potentially at 3 times the price. The all-in-one box, I think, is 3 times higher in price than the most separated box, right? And what's the difference in price? Us having to do all the separation for you. With that said, people are really willing to buy convenience. We find that people are open to spending more to have that extra convenience. And I think this is the whole point. It's a balance of convenience versus cost. Now, that's in my model, right? Where I am legally obliged to make sure everything is recycled. That's very different than a traditional recycler's model. Because in a traditional recycler, they are not legally obligated to recycle what they collect. In fact, you could fill your blue bin, your recycling bin, with everything you are told to fill it with, and the recycler could throw it all out and you'd have no legal recourse. Right? It's really important. So what is really a traditional recycling model that's not like ours, but a traditional recycling model is urban mining. They are telling you what they would like you to put in the bin, then they put on a conveyor belt and sort out what they can actually make money at. Now, and there, it's the idea of contamination is a really important vector, to think about, because it will make the purity of the feedstock go down and its profitability diminish, right? So I just want to sort of compare and contrast in that sense, because we run very different than what one would call a normal, a traditional recycler.
Yeah, and also what I have heard, like we as consumers, we typically say plastic and plastic recycling. There is no such thing as plastic, because even within plastic, I'm like, at least as far as my limited knowledge goes, there's so many different variants. There is polyethylene and polypropylene and HDPE, and and how does that play into when you look at it as recyclable, or you look at it as being created? And you mentioned, like, you went that specific, that this blade will convert into something else. And so how does that play when you look at within plastic, how they are mixed up?
Absolutely. So you're absolutely right. Within any category, alloys, fibers, polymers being plastics, there is a whole subcategory. I mean, we're just like, when you say something like alloy, that's sort of like saying animal, and then there's lots of animals. If you say something like plastic, it's saying like plant, and there's lots of plants, right? So in all these categories, there are these subfamilies, if you will, and it's important to be aware of them. Now, let's double click to your question in the world of plastics. In plastics, when you look at the identifiers, we tend to like to split them into 7 categories, and that's seen by the plastic identification codes as number 1 through 7. Basically, number 1, 2, 3, 4, 5, 6 are specific type of polymers, and number 7 is just everything else, unknown, right? So it's not really 7 true families, it's like 6 big families and then a bunch of mutts, where you just don't know, what they are. Now, again, a traditional recycling model is going to say, I want the really good stuff, which tends to be number 1, PET, in a clear, rigid, and food-grade form, like a water bottle, and number 2, HDPE, likely like in rigid, natural color, large format, like a milk jug, or maybe a laundry detergent container. Sometimes rarely, companies go after number 5, polypropylene, and then the rest they tend not to, because those are the ones they can make money on, right? That's a traditional model. In our model, we are obliged to recycle, whatever comes in. And so, for example, the way we recycle polymers is we get them into their major families. But if we create, let's say in the world of cosmetics, a polypropylene division, there's still going to be a bunch of contaminants in there, maybe at 10%, or 5%. Things like different little things, that were attached, maybe to that item, or somehow difficult to, maybe they're laminated together or something along those lines. So what we create is a compound polymer. So basically, it's vast majority polypropylene, with a bunch of sort of miscellaneous in there that may affect things like color or other characteristics. And then when we're out there, or our partners are out there finding plastic buyers, we're looking for buyers that can use those materials in their inputs versus virgin. And in some cases, we may have to add additives to get to the right output so that that user can absorb the material. But we are less focused on maximizing the value of the material. We are most focused on making sure everything has a recycling output. And that is fundamentally different than, again, traditional recycling.
Yeah, two products that come to my mind that actually intrigued us early on when we sort of realized what we were here to do. And these have been challenges that we've been toying with, and I'd love to get your insights because you're so deeply, you're so deeply embedded in a way in the whole idea of what is waste. One is the multi-layered substrates. And of course, we create these ingenious products that can last, 6 months, 12 months of shelf life and taste good. The material inside it tastes good after that. And of course, they're created to build barriers for air and moisture. And the other one, which is a lighter product, like a styrofoam, a polystyrene, where again, it's created more for one-time use, and it's going to go away very quickly, but then it's mostly air. And again, it creates a challenge. So those two products have always intrigued me, and I'd love to get your perspective on
Absolutely. So let's start with the first, flexible films, right? In the world of flexible films, and it's everything from a pet food bag to a shampoo sachet, right? You have, typically, the world has been what you would call these multi-layer laminates. Multi-layer just means multi-material types laminated together. Like a chip bag, it's polypropylene with an aluminumized layer and, and some ink and so on and so forth. What's interesting is there's two parts. I'll tell you how we look at them, but then where are they going is they're actually trending, the family of multi-layer is trending into more complexity. We are seeing now a lot of manufacturers move from multi-layer, multi-material to multi-layer monomaterial. That's a new sort of vector. Many suppliers are staying in the multi-material, multi-layer category, and then there's the whole emergence of degradable packaging forms, from biodegradable, industrially compostable. The worst probably would be oxo-degradable, but different forms of degradation. Now, that's actually creating incremental complexity, right? And it's going to be very interesting to see, what happens with all this complexity. A lot of it's going to hit by 2025, would be my prediction. Now, what we do when we get multi-layers in, we still try to keep them by family, right? So we can take all multi-layers together, but it creates a much more expensive process. It's much easier for us to collect cookie wrappers, chip bags, bread bags, pet food bags distinctly, because then you're already harmonizing two things. The obvious thing, which is the material composition, but there's an unobvious one that tends to be forgotten but is critically important. The contamination type that is on the material. Like, think about it, right? A bread bag is going to have mostly crumbs. A chip bag is going to have oils and crumbs. A pet food bag is going to have grease and crumbs. But then a shampoo sachet is going to have surfactants. And keeping those distinct allow a better process to be able to get to a clean material, because in something like say, pet food packaging, we have to take it, shred it, and clean it, because you got to get all that, all those oils and greases off. Because if you don't remove the oils and greases, it creates air pockets and bubbles in the output plastic. Because in the heating process, it will create these little bubbles, and bubbles create a lack of strength, right? It's just missing content, if you will. So basically, what we would do is shred it, clean it, and then create again a compounded polymer. Something like a juice pouch is 96% polyethylene, 4% aluminum. We won't take the aluminum out; we'll keep it in there, and it acts as a filler. And we found that that's a more economic way to handle juice pouches than somehow trying to separate through a chemical process the aluminum from the polyethylene. You tend to be able to get the aluminum out, but then you tend to burn the polyethylene. And that's something that we would like to avoid. So that's on something like flex films, right? The big issue, I think, in flex films is it is the archetype of where all packaging is going, which is cost reduction. And the irony of cost reduction vis-a-vis recycling is the more you reduce cost, the less recyclable something becomes. Like think about beverage containers. Beverage containers, if they're in aluminum, get recycled in the US at like 60, 70%. If they move to PET, they get recycled at like 25%. If they move to cartons, they get recycled at 11%. They move to pouches, outside companies like TerraCycle, they get recycled at 0%. All four of those are technically recyclable. It's just they're progressively less profitable to bother recycling. And that's a really important sort of message is that's the driver, if you will, of recyclability is value, right? And we are actively removing the value. And we're doing that for good reason, but that's the output effect. You asked about something like styrofoam, right? In the world of styrofoam, the big, of course, again, it can be recycled by being melted down. It's not as much of a recycling issue. The biggest issue on styrofoam is transporting a lot of air. And so it becomes very uneconomic for it to be moved around, right? It's sort of like potato farming. Potato farming, you have to really get your potatoes locally, because if you're going to ship them very long distances, they're very heavy, low-value things that you can't move them too far, right? Styrofoam is very similar. It's a very inefficient way to move plastic around, right? Because you could have either a pallet of plastic or like 100 pallets of styrofoam, and it becomes the same amount of sellable output. And so what's really important in styrofoam, if you're going to do it, is I think the compression locally, like getting it compressed into a way that it can be efficiently moved around. And that could be done through mechanical compression, or it could be done through chemical compression, like put it into a solvent that allows it to, basically solubilize into a drum.
And I presume the styrofoams would also have a lot of contamination, but I guess those have to be dealt with in all these cases anyways.
Always. In some you have to deal with. The contamination could be dealt with by cleaning, by somehow removing, that could be through a mechanical or chemical process, or encapsulating it. Yeah. All three are choices.
You talked about aluminum. That was fascinating as well. So again, where the background I come from, it's a very informal economy of rag pickers in India. And what I noticed was, again, similar to you, like if it doesn't have economic value, it's not going to be picked up. And that was again where my question came from, multi-layered substrates, styrofoam, and you answered it succinctly, why and why not. So what happens? So you have a beautiful economic model where there are producers who come in and support a certain program. What would happen if that was not the case? Would some of these products, you would not be able to deal with some of these products? You have a wonderful program I saw about with Taco Bell, and like those are multi-layered substrates. What would happen then?
They go away. They would disappear. The central issue on recycling the things we recycle is money flow. And that's the dependency, is making sure that there's the money flow, because on its own, it doesn't make sense. Like you mentioned rag pickers or waste pickers in India. I bet you if you and I were sitting on the streets in like Calcutta or wherever, and we put an aluminum can on the street, and we were we're just watching it, it would be gone, just like you said. But if we left a Tang pouch or a shampoo sachet, it would sit there all day, right? That's the point. Now, if we said, here's a shampoo sachet, and we'll give you 1,000 rupees or whatever to take it, someone would take it. At a certain price, someone would take it. I have this, actually, let me play a thought experiment with you, because I have a really good way we teach our team. Actually, earlier this morning, we were training some of our new team members, and this was the thought exercise we used. So here's the experiment. You ready? You and I are in a room, and I'm going to put an object on the table, and you must leave with it. You cannot refuse leaving with it. It's you, right? It's not like you're not someone else. You're not a garbage company, or it's quite literally you, and you must leave with it. And you must leave 7 out of 10 happy. So like happy, but not ecstatic and not sad, right? And the only way you can modulate your own happiness up or down is you can modulate your happiness down by giving me money, or you can modulate your happiness up by asking me to give you money in addition to you take. But you must leave with the object, okay?
Yep.
You ready? A kilo of gold.
Definitely take and run.
No, you have to take it. That's not the question. How would you modulate your happiness to leave 7 out of 10?
Well, I'll leave at a high level of happiness.
No. You must at a 7 though. At a 7. Do you pay me? Do you ask me to pay you?
Well,
do you take it for free? How much?
I pay you whatever the going rate of gold is.
No. Right now. It's you.
I have no idea what the gold costs.
Well, make a number. Make a number that makes you happy without having to look up the price of gold.
How much did you say? A kilo of gold. A kilo of gold should be maybe $10,000 or something like that.
So how much would you pay me? Again, you're not a gold dealer.
If I can pay you 7,000, I'll be very happy.
Great, 7,000. Okay, cool. That was object one. Object two, a kilo of iron.
A kilo of iron. So again, similar, whatever it costs, if I get a 20-30% discount and I pay you that, I'm happy.
But okay, so give me a number. You gotta give me a number.
Okay, maybe $700.
Okay, or even maybe even less, right?
On what it is, yeah.
Okay. Now, last object. A kilo of human shit, but it's in a bag, so you can take it with you, but you must leave 7 out of 10 happy, and it's a kilo of human fecal matter.
I would definitely not be paying you, and if you pay me something, I would leave and put it in a compost.
Well, how much would you want? You have to leave 7 out of 10
A
happy.
kilo of poop, maybe $10.
Okay, now, waste management companies must leave, unless the waste is informally disposed, like littered, right? But if it's a waste management, must leave happy. They can't refuse, right? And most things behave like the waste, where you're going to have to pay them to take it, and the best they'll do is just then say, I'll put it in a pile somewhere, or put it in an incinerator. Recycling is the gold. Now, in the real world example, the gold is an aluminum can, and the poop is a coffee capsule. You see what I mean? In the real world example. I just used hyperbole to make it a little bit more fun. But like you asked me in the opening question, right, in this exchange, what happens if the funding disappears? Then it all goes away. It would be similar to saying to a recycler, what would happen if the price of aluminum collapsed? They would stop recycling aluminum.
Do you see there being a natural set of economics that could be created if the material itself was different? If say the material, of course, the world we work in, and this is coming from my jaded perspective, so take it as that, is that everything became compostable, and there was composting systems, and hence everything became carbon again. So is that too utopian an idea, or do you think that's something that could be worked on?
So let me answer it two ways. First, directly in the degradable space. Even composters need to be paid to take material. I was giving a lecture yesterday in Kentucky, and someone asked me, what's the value of organic waste? And the answer is it has negative value. So we're, for example, the world's largest coffee capsule recycler. 97% of a coffee capsule is organic material, like coffee, right? Coffee grounds. And that's super rich. You would love that as a gardener. It makes really good output. I still have to pay a composter a tipping fee to take it and compost it. They won't take it for free, because that's what their economic model requires. So if we were to hypothetically move to a world of only compostable materials, we still need to have a money flow to encourage the infrastructure to exist to take it, right? The joke is, if you wanted to have a perfect circular economy today, I have the answer. Make everything from solid gold. And you don't have to have any new you could litter everything on the street and it would be picked up in a minute. Now, you won't sell anything, but you would have a perfect circle. If you then go to so that's on compostables. Now, if you shift over to your greater question, what are the vectors? I think there are 3 vectors that a producer can look at to improve the circularity of their product. 2 are voluntary, and 1 is not voluntary. The non-voluntary government intervention really comes in the form of some form of legislative intervention. It could become in the form of banning things. We see the bans of single-use polymers all across Europe, straws, plastic bags. That just says you can't make that anymore. And then you'll have to adapt. You could also do DRS, deposit return schemes, where you pay a deposit, which always will encourage more collection relative to the value of the deposit. And you could do EPR, extended product responsibility, which is a tax on everything that then is used to invest in the recycling and composting infrastructure of that country. All of these things are good. They're being enacted in different ways all over the world with different results, right? But they all have an output, which is they increase the price of the product. Let's be clear, right? The full out picture, because all that tax has to go somewhere. The next option is a voluntary bucket, which is increase the value of your good, right? It would be like, how we talked about beverages can go aluminum cans to PET to carton to pouch? Well, go from a pouch to a carton, or go from a carton to a PET bottle, or PET to aluminum. Those move you up in the value hierarchy, right? So there's more value to go mine. It just will directly increase the cost of every item you produce. There's a reason it's downhill towards the pouch, because the pouch is cheaper than an aluminum can. But if you went uphill, you would increase value and circularity. The third is voluntary as well, which is create your own take-back system and create your own loop, if you will, and take responsibility to be able to offer solutions to collect and bring back your material. That's our business model. And it's not just through TerraCycle, but other organizations can offer these sort of things, or you can build it out yourself. And that is then a cost for every item that is collected and recycled. So either way, it's cost in all cases, but those are the three different sort of outputs one sees. And I think in the world of degradable, right, the key question to ask is, what is today's infrastructure in the country where you are implementing the degradable solution? And how do you make it that infrastructure wants your degradable solution in the feedstock? What interventions can you do? And then how else can you ensure that that opportunity exists for the consumer to take part in it?
So one of the things that I've noticed is, again, it's all systems thinking. It's all, everything works together, and there's a loop out there. And one of the challenges, at least in the domain that we work in the compostable packaging space, is to do with the use of compost. And I'm linking it to your economic thought. So till there is not enough demand for compost, it's not going to, everything else is a feeder to that. And so what happens if there is a higher demand created, and this goes to land use and how we are using fertilizers and, everything you mentioned, NPK earlier. So what happens if the land systems change, the way we grow things change, and the demand for compost goes up? Do you think then there'll be a different economic value created into the products becoming more compostable?
Yes. I think the vectors I would look at, if I was in your shoes, let's say, right, and I'm thinking about compostable packaging or compostable outputs, right, there's a number of different vectors that I would look at. How do I positively influence? Okay, so one is the economic model of the composter. One is, how do I make sure there's more demand for the compost at a higher price? Right, so more demand at a higher price. Then, how do I think about the input economics? Right, one of the challenges composters have at the moment with plastics, right, whether they are compostable or not compostable, is consumers mix them all together, right? And now you have this wide range of degradables, from home to industrial to even OXO, and then there's plethora within that. It's all spectrum, and then some consumers are putting in petrochemical products. Now you have a wet feedstock, right? You can't just use a NIR machine to blow it all apart. It's really important to think about how to help composters be able to do good separation, get the petrochemicals out and the things that are not suitable to their system out, so they can throughput the good stuff, right? We do that, for example, we do a number of composting take-back programs, whether it's chip bags or diapers. And the way we're able to do that is we have to find certain composters that we then fund to put that intervention in, and then you can do it. The next vector is actually the amount of composting infrastructure, right? In the US, 4% of Americans have access to curbside composting. That needs to improve. And what are the vectors to help achieve that? That's another important one. A third, could be how to help on home composting infrastructure. I think it's something like 10%. I know the American numbers; it's different everywhere, but I think 10% of Americans home compost, right? And then the next vector is how to make sure consumers know how to get from making the right purchasing decision to a good end of life physical decision, right? In the purchasing decision, it's really important that for consumers to know that there's different forms of degradable, and how to make sure that they are helped to pick the right one and not the wrong one, and that then they know what to do with that package once it's done. Because if it ends up in a landfill, it's not that much better than anything else. It's going to mummify or turn into methane. Either way, the real win is for it to be degraded properly and turn into good output like compost. And these are the various vectors I would look at. And again, it's going to be different country by country, because you also have to look into, for example, in a country like India, where a lot of the landfills are more informal, right? They have lower compaction, higher access to light, huge percent of organics in there. I think it's like 40% organic or
70.
more. Compostables are, I think 70, excuse me. So even more. Very good, right? In an American landfill where it's less than 10% is organic and you have very high compaction, the answer may be slightly different, right? So it's also making sure you think about this in the local geography in which one is implementing.
Yeah, it's interesting that you mentioned that, and I remember we were looking at using municipal solid waste as a fuel, and that's the challenge most of these companies faced in India because the high level of wet or organic matter.
It would burn all at negative caloric value.
There wasn't enough calorific value to be able to use it for energy. So, they had to shut down these big investments and big plants that were created. They didn't understand that the municipality will not be able to provide them with a very dry, good fuel.
You know what the irony of this statement is? Take a country almost in the opposite end of the spectrum, the Nordics. Denmark and Copenhagen and so on, they built big incinerators. And you know what's fueling them all is the country's recycling. Because plastic has phenomenal caloric value.
They're buying. The Swedes are buying garbage.
Oh my God. And you think you're recycling only to feed an incinerator in a country that could easily have afforded, because circular economy is a luxury, let's be clear, right? In modern disposable consumption, the more access you have to circularity, the richer you are, right? The irony is the older ways of living were intrinsically circular, right? But that's before disposability. With disposability, the more circular, the more money you have to
spend.
And
the similar argument I got in Singapore, we were trying to introduce our products there, and the government said, but why should we ban plastic? We are using it for incineration, and then what will we do with that? We need that fuel. So it was very interesting.
And these incinerators, they're dangerous because they have to run at high capacities.
They have NCGs. You can capture the non-condensable gases, but you still matter will just change
even if you capture all the carcinogens and the nasty stuff, and who knows, right? Question mark. I can't say one way or another, but it's a question mark. There's still a tremendous amount of carbon.
Absolutely, you're losing that carbon as well. So I'm going to switch to, and also looking at the time, I'm going to switch to the process. So one of the things I've constantly been taught is that there is no such thing as recycling. It's only downcycling. And eventually, least where I see it, it comes into that black poly bag kind of thing, which cannot be converted anymore, apparently. That's what I'm told. So what do you think about the idea of downcycling and not recycling?
Yeah, sure. So I've had a fun debate with my friend Bill McDonough for 20 years, who's the gentleman who invented the word downcycling in his seminal work.
He's one of our mentors, by the way.
Now, okay, so you know Bill. Okay, so the downcycling first is a very challenging choice of words because it's a very negative term. It is seen as an insult almost, as a negative. It's no way trends positive. Now, in Bill's definition, you have a material, and you could, again, there's two versions of this definition. That's why I say in Bill's definition, you have upcycling and downcycling from a material starting point. Downcycling would be that it goes into something lower grade, like a food grade container, bottle, like a water bottle into a shampoo bottle. That would be downcycling, right? Or bright white paper into corrugate would be downcycling, or corrugate into toilet paper, right? Those are all downcycles. And upcycle would be, well, turning the shampoo bottle into a water bottle, or the toilet paper into corrugate, or the corrugate into bright white. Now, in that definition, 99% of what you call recycling is downcycling, and then you only would ever have things that are closed loop, which would be linear, and there's no such thing as upcycling. Upcycling in that case is an academic term, right? Because if you can move the material up, then this was probably over-designed, right? That's one option. Like maybe you made a food grade plastic for something that doesn't have to be food grade, as an example, right? Or it was through a ridiculously expensive process like chemical recycling, where you could go polymer to polymer and can go from non-food grade to food grade. That would be an upcycle, but it doesn't really happen in the real world because it's absurdly expensive. So it's more like academic laboratory settings. So let's just first note, everything out there in recycling, and a lot of what we do too, you would call downcycling, but downcycling is recycling. They're synonyms. It's the same thing, and it's where the vast majority goes. If you pick up a cosmetic product, any cosmetic product in the world, and it says made with recycled content, that's soda bottles. That's a downcycle. If you buy a t-shirt made from recycled content, that is likely soda bottles. It's a downcycle. It's all, the only time it isn't is a Coke bottle into a Coke bottle, right? That's the only time. Now, so I think, one, the word downcycling is dangerous, right? Because it gives the perception. People many times say, oh, you're not recycling, you're downcycling, but downcycling is the most common form of recycling, right? Even in a way, taking a a really refined compostable package and making it into soil, you would call it downcycle, right? And so I think it's so important people understand that they're the same thing. It's just this really sort of unfortunate term on it. What we look at in the hierarchy of waste is a slightly different. We don't use the word downcycle, but we look at, what is the hierarchy of waste? And we would say the best is don't buy. That would be a synonym of reduce. Then reuse, upcycling, recycling, energy, disposal. Now, in this definition, imagine that I have a cup in front of me. Now, this cup is made from glass. That's its composition. But it's not just glass in a pile. It's glass looking like a cup, so it has a form. The form also costs money to create. And it's a third concept. It's an idea. This glass, in this form, is meant to hold a cold beverage. Frankly, it couldn't hold a hot beverage because my hand would get scalded. A hot beverage cup has one of these on it, right? One of these handles, so I can hold it, right? So this is a cold beverage cup is the idea, looking like a cup, glass. It's those three things. Reuse would be where I clean this out and fill it again, which is what I'm going to do with this. That is where I valorize all three things, the composition, the form, and the intention. The popular definition of upcycling, which is if you type upcycling into Google and go to Google Images, it's like sewing juice pouches into backpacks and so on. That would be like me turning this into a pencil holder, where there I'm still valorizing the form and the composition, but not the idea. Now it's a pencil holder and not a beverage container anymore. Recycling is where I value only the composition, not the form and the intention. And then I shred this and melt it into a new glass product. And below that would be incinerating, where I would value only the caloric value of the composition. And then disposal is where I value none of it. And I look at the whole thing as a liability. That's how we would look at it, because it hierarchies on both the popular definitions and what is best and worst for the environment. And again, I would be like this whole term downcycling. You could see I would really advise caution in how to use it, because I think it creates for the layperson a lot of misunderstanding.
Yeah. So the way you say it, it's probably changing its usage, but it's not down or up. It's still re.
It's just changing. Now, when you change usage, right? You go from material A to material B. The goal is that you degrade quality the least amount, right? So it would be better to go bright white paper to corrugate to toilet paper than bright white paper to toilet paper. Then that's a shame that you're losing that. So one is you want to go down as little as possible, because everything degrades, right? Everything has a slope of degradation. Paper can only be recycled 7 times, plastics 10 to 35 times, and so on and so forth. Everything has a degradation curve, so make it degrade as little as possible. That's one vector to look at, so the drop. The other is what will be the lifetime of where you get to. So, like, for example, if you turn a toothbrush into a Frisbee, maybe the Frisbee lasts 3 years. If you turn the toothbrush into a playground, maybe the playground lasts 40 years. So it's also how long is it going to function in that new form is another vector that's very important to look at.
Fascinating, and I will have a couple of follow-up questions depending on time. But one of the things that I want to cover is, again, what I've seen in the process of recycling is the whole energy that is spent in the whole process. Somebody collects it, transports it across the world, recovers 50% of it, using 60-70% of the energy that would be used for a virgin material, ships it all the way back. So that's, of course, a dangerous proposition in some ways, because you're not seeing there's a lot of hidden things that are going on in order to be able to create the economic value So how do you see that whole process of recycling?
Absolutely. Yes. So first and foremost, you are absolutely right in that recycling requires energy, right? You have to transport and process. We have a whole LCA department. Have done a lot of life cycle analyses or LCAs on this. One for us, I'm not going to speak, there's two issues with the way what you described, which is the most common form of recycling, is that it's shipped halfway around the world, or around the world, basically, and only 50% of it is valorized. And then a lot of the other 50% is informally disposed, creating ocean plastic and all sorts of problems. So the way we look at it at TerraCycle is, one, we only process regionally. So North America waste is in North America, Brazil waste in Brazil, Europe in Europe, and so on and so forth. We do regional processing. And so it doesn't leave the regions. That's very, very important. And then we also focus on recycling everything. So it solves those two sort of key pieces. I can speak for our models because that's where we've done our LCAs on. And there what we find is that a TerraCycle recycling model is somewhere between 50 and 75% better from a carbon emissions point of view than disposing that waste, which would be the alternative if we didn't have our models, because we're only running on things that are hard to recycle. And the disposal, we look at landfilling locally, incinerating locally, and incinerating with energy recovery locally. Now, if you move to reuse, that's about 40% better than recycling. And the reason for these improvements, I don't know as much on the degradable, so I can't speak to that as much, but I know on the non-degradable, what does that look like? And the reason is the biggest environmental cost is making things. It's the farming and the mining, right? So when you use recovered content of some kind, whether it's reuse where you valorize everything, or whether it's recycling where you valorize just the composition, or upcycling where you valorize everything but the idea, the intention, you don't have to go extract those materials from the earth again. And that is avoiding that very destructive process of mining, farming, whatever the extraction would be. That is most. Like, so for example, if I have a cotton t-shirt, most of its environmental impact is turning soil into cotton, less so where it was made and how it was woven and so on.
And this reminds me of a very interesting conversation I had with one of our customers at General Mills. And I was pushing him to move to a more compostable packaging. And this was way back, it's maybe 10 years back. And we were not ready. We had a poor product. And he explained to me very similar to what you're talking about. He said, imagine the amount, he just talked about potato chips. And he said, imagine the amount of energy I've spent in having those potatoes grown, transported, segregated, washed, converted to chips, put in a bag, and then taken to market. And if something goes wrong with that bag and it doesn't perform, imagine the impact of that. And that was a huge wake-up call for me. Like, what is my dharma as a packaging provider? It is to protect what is inside. And if I don't do that, everything else is just immaterial.
And that's 99% of the impact. It's a potato chip bag's impact. Yeah, it's like probably 3% packaging and 97% agriculture.
Okay, so one more thing, because I know again I'm almost out of time. So you're making such amazing plethora of products from these substances. How do you decide? Because there is so much. Like, as you've spoken, I've realized that there is so much complexity in the input, and that determines the output. But even the output, you have to ultimately have a market for the output. And how does that work? How does that whole machinery work?
For us, where we put our line is we don't make products, we make raw materials. And the reason we focus on raw materials is that we found is the sweet spot in managing complexity. If we had to make finished goods, oh my God, the complexity would be 100 times more, because you got to make a good, you got to market it, you got to deal with its inventory, all this stuff. In raw materials, our key output, and that becomes much more manageable.
That clarifies a lot of things. And I think that's very valuable as well. As we are looking at expansion as well, we realize that we have to play on the base level. You cannot try and make the final product because then you can't scale to where that takes.
No, it's a different business.
Absolutely. You need to be much more adept at understanding what the market needs and whether that performs. And those are different people. Like they're going to do their work, and you're going to provide the raw material. And that takes me well towards my closing questions. How do you see TerraCycle from, and you can decide the timeline, 5 years, 10 years, whatever is the way you think. Yeah, the future. How do you see that in terms of impact, in terms of scale? What do you want to achieve in the next few years?
Look, we view that there's so much innovation still to be discovered in the world of waste. And we want to become like the Google of garbage. Over the next 10, 20 years to become one of the largest waste management organizations out there, but really playing in places that have never been played in before. And we feel good about so far what we've achieved over our first 20 years. And we have a lot more appetite to see where we're going to go.
Super, Tom. One thing is clear, you have no dearth of ambitions. So that's wonderful. It's wonderful for the planet. No. And that leads me to my final question. What does good garbage mean to you?
Good garbage. That's a good question. Depends on the vector, but one where you can access the value. And I would say not just the obvious. the material value, that's the obvious, but all the other types of value so that you can, so that it doesn't, the best type of garbage is something that really isn't garbage in the end.
Super. And actually, I couldn't even mention this because there's so much to talk about. But the four books that you've
Yes.
already written, and one of it is called "Make Garbage Great,"
Yes.
and that was
That's right, that's
such
right.
a
Yes.
fascinating correlation to what our final question normally is. But well
Yeah.
put. Thank you, Tom, for your time. This has been a fascinating discussion and a lot of learning for me
Wonderful.
because I come from a different perspective to the same challenge. But
Of
thank you
course.
for sharing your thoughts. Thank you for the amazing work that you do and, trying to bring this all together. I know there could be challenging times, but, the things you're doing are going to have a positive impact. And I'm definitely looking forward to the legacy you leave behind. Thank you for being in the show. Thank you for this conversation. I hope we get another chance because there's so much more I wanted to cover. Thank you, Tom.